I copied this example from the SDK in my Ubuntu development machine from this location. So when I set up my Ubuntu machine for CUDA development, it came with some examples. COPT is an acronym for CUDA Profiling Tools Interface. I modified this example by adding a new makefile to instrument the build for purposes of computing code coverage from this CUDA example. I also added a script to show some details of my CUDA development machine. So in my CUDA development machine, I have these versions here. A CUDA development machine needs to have a working compatibility of different components. If one of these is not compatible, you will encounter some problems. You can compile, but you cannot run, or you may not be able to compile at all. This makefile.conf is to build an instrumented executable using Parasoft C++ test, CT. I installed that in this location, and I wrap all of the steps to build, to run, and to generate report using these make commands. First, let us take a look at the source code, the CUDA C++ source code, and the pure C++ source code. So the CUDA code, we have this usual main entry point, and then I'll just highlight a few lines here of interest, like these triple brackets, which is one of the extended C++ aspect of CUDA programming. So it's not your usual C++, only compiles with an NVCC compiler provided by NVIDIA. And others would be this global keyword and these block-dim magic variables. The rest looks like C++ or C, but since it has a presence of these triple brackets, this whole file needs to be compiled with the NVCC compiler. The other file being pure C++. This pure C++ can invoke functions from the first file that we just browsed. It can do that, but this one does not have those extended CUDA keywords. So G++ is used to compile this one. And this file is the one that we can instrument. Let's do that. First, I will build the instrumented executable. And that instrumented binary is this one. This one contains both the device code and the host code, or other way of saying CPU instruction and GPU instructions. To compute code coverage, we need to execute something. We need to execute the instrumented binary, which is this one. So I wrap that using a make command as well, this one, because there's an environment variable that needs to be set. So this is the output of that executable. So these are the print statements inside the source code, and this is the environment variable that I was telling about. This is documented in the SDK as well. As a result of the execution of this instrumented binary, we now have the coverage log file, this file. Out from this cpp test results.clog, we can then compute the resulting coverage. I just configured this for line coverage and decision coverage. So to generate a report, I will type this one, report 2. And now we have this HTML report. I will open a browser to view the coverage matrix computation. LC for line coverage, DC for decision coverage. There are other types of coverage that I did not include here, such as MCDC and around 9 others, like path coverage, block coverage, decision coverage, statement, and so on. So the coverage is this one as usual.